All right, so today what we're going to do is learn about triple T's. And triple T's are so awesome, I had to bust out a picture of Mr. T. So just to review, so far this year we've worked with single and double T charts. Now we're going to up our game and crank out a triple T chart. The only difference from what we've done to what we're doing is you need a balanced equation. Without a balanced equation, you can't do these charts. With that equation, though, you can get anything about any item. So the equation we're going to work with is this balanced equation right here. 3 hydrogen plus 1 nitrogen goes to 2 ammonia. Now, just as I've given you a setup previously, this is the format for how to tackle triple T charts. As before, your given's going to go in the far upper left. What you want's go in the far upper right. Your unit to cancel your given's going to go here. Then the only difference is you're going to go to the balanced equation to fill in this piece right here to make this work. So I'm going to show this with you with the problem up above. Given 70 grams of nitrogen, how many grams of ammonia can you generate? So I have that set up here. So what I'm going to do is I'm going to go ahead and input 70 grams of nitrogen into the far upper left. What I want is grams of ammonia. The molar mass for grams of ammonia is 17.03 grams of NH3. To get rid of moles of nitrogen, I need to go to moles of nitrogen. So 1 mole of N2 on the periodic table is going to be 28.02 grams. Then to go from nitrogen to ammonia, I got to go to the balanced equation. Right up here, here's nitrogen. I have 1 mole of nitrogen from the balanced equation. So I'll write 1 mole of nitrogen here. Also from the balanced equation, I have 2 moles of ammonia. So I'll write 2 moles of ammonia here. Then what's going to happen is I need to have 1 mole of ammonia down here. Finish this out. I know I set this up right because I'm going to end up with grams of ammonia. And everything, as always, should cancel diagonally on the T chart. So in my calculator, I'm going to input 70.0 grams. I'm going to divide by 28.02. I'm going to multiply that answer by 2 and then multiply it by 17.03. When I do that, the answer I get is 85.1 grams of ammonia. This slide here is just a more formalized version of that. So it's the same thing I did on the previous slide, just a computerized version cleaned up for your viewing pleasure. Let's go and do one more problem together. So this time I'm given 40.0 grams of hydrogen, and I want to know how many grams of ammonia. Same balanced equation. So my given again is going to go in the far upper left. So it's going to be 40.0 grams of hydrogen. What I want is grams of ammonia. That's going to go in the far upper right, which is going to be 17.03 grams of ammonia. Then what I need to do is I need to get rid of grams of hydrogen. So 1 mole of H2 is 2.016 grams. As before, I need to go to my balanced equation for this. From the balanced equation, I have a 3 in front of hydrogen. So I'll have 3 moles of H2. And I'm going to go to 2 moles of ammonia. And then to get rid of that mole of ammonia, I'll have 1 mole of ammonia down here, which is the molar mass already put in. So I'm going to take 40.0 grams divided by 2.016 times 2 divided by 3 times 17. And that'll give me the answer, which is going to be 225 grams of ammonia. Here is the more formalized computer version of that. So here's one I want you guys to try in a second. So I have a new equation. 3 iron plus 4 water goes to Fe3O4 plus 4 hydrogen. Given 100.0 grams of water, how many grams of Fe3O4 can this generate? So what I want you guys to do is have a sheet of paper, or pull up something separate on your iPad, work this problem out using the system, pause the video, then you can go to the next portion, and that'll have the answer. All right, so here's the answer. Our given's going to be 100.0 grams, which goes up here. I'm going to divide that by grams of water. I'm going to divide that by 4. I get the 1 and 4 from the balanced equation. And then 1 mole of Fe3O4 is 231.55 grams. When I punch that into my calculator, I get 321.2 grams. That's how you do triple T charts. Again, if you have any questions, you can ask me about that in class. Thank you.